Okay, I'm going to begin section 8.1 now. We're only going to do 8.1 in chapter 8. So the topic here is the distribution of the sample mean. Remember from chapter 1 that a statistic is defined as a numerical summary of a sample, and a parameter is defined as a numerical summary of the population. And those, of course, are two different things, right? Are you talking about the sample, or are you talking about the population? If you read about a information that has been told to you. In a statistical study, we often calculate a statistic and use it as an estimate for the parameter. Okay, X bar is going to estimate mu, and S is going to estimate sigma. So let's take a look at, here's an example. It says, height of adult females in the United States. Suppose that the research objective of a study is to find the mean height of all adult females in the United States. As part of the study, we take a sample of 100 adult females in the United States and then find their mean height to be 63.4 inches. Okay, if we wanted to know the parameter and the statistic in the study, the parameter would be the average height of all adult females in the United States, which is something that we would never be able to know, okay? Because it's not possible and not reasonable to survey the entire population, okay? It is just too big. Now, the statistic is the average height from the 100 adult females in the United States, and that was found to be 63.4 inches. Problem 1, suppose that we take another sample of 100 adult females in the United States. What would you expect their mean height to be? Well, I would guess that it would be around 63.4 inches also, okay? It would be very unlikely for it to be exactly 63.4 inches again. It could be, but that's unlikely. But you would expect that it would be around that number, okay, based on this one sample that was taken earlier. Now, the idea in this section is to select several different samples of a certain size and observe the means of those samples. Okay, and we'd like to know how the means compare to the actual mean and how the means vary about the actual mean. There's a note there. Each different sample will have a different mean, right? Like if I find another sample of 100 adult females in the United States and calculate their mean, like it's probably going to be a different number than what I see here. If I do that again, I'll get a different number, likely. So each of these means are going to be an estimate of the population mean, which is the parameter. And again, that's the thing I don't know. But I'd like to have an idea of what the parameter is. I'd like to have an idea of what the average height of all adult females in the United States would be. Okay. Statisticians are interested in knowing how the means of samples of a certain size taken from the same population vary about the population mean. Because statistics such as X bar vary from sample to sample, they are called random variables. So X bar is going to have a probability distribution, and the goal in this section is going to be to describe the distribution of the sample mean. Okay, like how do these means compare to the actual mean, and how do they vary about the actual mean? That's going to be the goal in this section. Remember that when we describe a distribution, we do so in terms of the shape, the center, and the spread. Okay, there's another definition. Consider a population with mean mu and standard deviation sigma. The sampling distribution of the sample means is of this population is the distribution of the random variable X bar computed from all the samples of size n. The mean of all the possible sample means is represented by mu sub X bar, and the standard deviation of all the possible sample means is represented by sigma sub X bar. We sometimes call that the standard error of the mean. Now that's terminology that you'll see in the book. Okay. There are two properties of the distribution of the sample means that we need to know in this section. The first one, the mean of the sample means will be the same as the population mean. So mu sub x bar, that's the same as mu. So the idea with that is, to select many different samples of a certain size and find the mean. Like the more information that we have in front of us, the better. Okay. So like in the problem above, if I were to select another group of 100 adult females and find the mean, like it's probably going to be a different number than 63.4 inches. Okay, and if I do that again, I'll probably get a different number. But the more times that I do that, the better idea I'll have of what the actual mean would look like, mu. Okay, and in fact, if I were to look at all the samples of size 100 and find the mean each time, the mean of those means would be the same number as the population mean. Okay? So that's property number 1. The second property says that the standard deviation of the sample means will be smaller than the standard deviation of the population, and it will be equal to the population's standard deviation divided by the square root of the sample size. Okay, so how you calculate sigma sub x bar is you're going to take sigma divided by the square root of n. In the next video, I'm going to go through a demonstration of these two properties here.